Okay, today we're adding and subtracting with scientific notation. Let's begin. Lena needs to add the expressions written in scientific notation shown. Use examples to answer A through C. First, we're going to write each of these values in standard form and find the sum. So to write in standard form, we need to move the decimal 3 times to the right in both digits. So we have 1,500. Sum means to add. So we're going to add that to 2,200. So my total is 3,700. It said now write the sum in scientific notation. So our sum was 3,700. To write it in scientific notation, we got to move the decimal 1, 2, 3 times to the left. So it gives me 3 7/10 times 10 to the third power. It said using your solution in B, how could Lena have found the sum without writing the expressions in standard notation first? So take a look at the box. So because my answer 3 7/10 times 10 to the third is my final answer, her exponents could have stayed the same, which is 10 to the third power. And if you add the decimal place values, you get 5 plus 2 is 7. Bring down your decimal. 1 plus 2 is 3. Okay? So Lena, what she could have done, she could have added the first part of each expression and kept the power of 10 in her solution the same. All right, let's look at the second part. Now, you know, anytime you see one of these gray boxes, you know you need to study this part and learn it, because this gives you rules. If we're adding and subtracting with the same power of 10, the two scientific notation expression must have the same exponent. So that exponent, we call it the power. So the same power of 10. You'll add or subtract the first part of each expression, and you'll keep the power of 10, just like we did in the first example. It said, remember to check that the final solution written in scientific notation is a product. Product means multiply. Product of a number between 1 and 10 times the power of 10. Okay. So in examples 1, 2, and 3, we're going to find the sum. Sum means to add. Or the difference, which means to subtract. And we're going to write our answers in scientific notation. So our first one, our exponents are the same. So all we're going to do is line up our decimals. And we're to add because we see a plus sign. So we have 2 3/10. So we're going to keep the exponents the same, which is 10 to the 8th. And we're going to add our place values vertically. So 2 plus 3 is 5, and 6 plus 2 is 8. So 8 5/10 times 10 to the 8th is the final answer. Number 2, our exponents are 10 to the negative 3 power, so that stays the same. So I subtract 9 minus 4. Both of them are raised to the negative 3 exponent, so that will stay the same. 9 minus 4 is 5 times 10 to the negative 3 power. Number 3, our exponents are the same, so I don't have to do anything here but line up my decimals. So 5 and 42 hundredths times 10 to the negative 5. So in the place, if you don't have a number, you can put a 0 there. I typically don't, but most students do. So I'll add a 0 as a placeholder. And then it's addition, so I'm going to add vertically. 0 plus 2 is 2. 9 plus 4 is 13. Bring down your decimal, carry your 1. 1 plus 1 is 2. 2 plus 5 is 7. And I'm going to bring down my power to the negative 5. Okay? Number 4, it says Natasha needs to find the sum of 8 and 6500ths times 10 to the 4th and 43,000. It says set up the problem by writing both numbers in scientific notation, then find the sum. So the only number that's not written in scientific notation is 43,000. So I want to write that as a number between 1 and 10. So my decimal need to end up between the 4 and the 3. So I'm going to move it 1, 2, 3, 4 times. So this gives me 4 and 3/10. Because the number was greater than 1 to start, my exponent will be a positive 4. Okay, now that I have it written in scientific notation, I now can add up the numbers. So my new expression will be 8 and 6500ths times 10 to the 4th plus 4 and 3/10 times 10 to the 4th. So now I want to add my columns. So I'm going to add 8 and 6500ths plus 4 and 3/10. And both of those are multiplied by 10 to the 4th power. So I don't have a number here, so if you want to put a placeholder there, I'm going to put a 0 here. And I'm going to add vertically. So that gives me 5, 9, and 12 times 10 to the 4th. But if we notice, it said, what do you notice about the sum? So when we add these together, this is not a number written in scientific notation, because if it was a number written in scientific notation, it had to be a number between 1 and 10. So we notice that the first value is not between 1 and 10. It needs to be rewritten as scientific notation. So if I have 12 and 9500ths, if I want to put that in scientific notation, because the number is greater than 1, my exponent will be positive. I moved it 1 time, so that means my base was already 10. My exponent was to the 4th. But because I moved it 1 time to the left, I want to add 1 to that existing exponent. So my final answer is 1 and 295 thousandths times 10 to the 5th power will be your final answer. All right, flip the page. I want to give you a little hint and clue to add at the top of your page. Okay. If I'm trying to make the number larger, I'm going to subtract from the power of 10. If I want to make the number smaller, you're going to add to the power of 10. And let's go ahead and insert a number here because I didn't write the word number. So that first one, if we want to make the number larger, you're going to subtract from the power of 10. And if you want to make the number smaller, you're going to add to the power of 10. And what we're referring to is the number of times you move the decimal. So however many times you move the decimal, that's going to be the exponent we're talking about, okay? So it says, at times it may be necessary to rewrite one of the expressions so that each has the same power of 10. In each pair of expressions below, we're going to practice rewriting one of the expressions to have the same power of 10 as the other. Okay? So 7 and 5/10, if I want that exponent to be a 4 times 10 to the 4 power, I'm trying to add to my power of 10, which is number 2 up top, which means I have to make 7,500 smaller by 1. So that means I'm going to move my decimal one place to the left, and I get 7,500s. Well, because I moved it one place to the left and made the number smaller, I'm going to have to add to that power of 10 to make the exponent larger. So the one decimal place that I moved, I'm going to move it by adding that same number of spaces to my exponent, which is 10 to the 4 power. The second one, I'm trying to make my exponent 10 to the 4 match the 3, because remember, in order for me to add or subtract, I have to have the same exponent power on my value of 10, okay, on my base 10. So if I want to make my exponent smaller, that means I have to subtract from the power of 10 one digit, because 4 minus 1 is 3, okay? So because I made that number smaller, I have to make my first digit larger. So I have to move this one place to the right. So my new number is 26 times 10 to the 3rd power. So all we're doing in this section is rewriting the current values so that we can have the same exponents on our base 10. Let's look at the second example. 1 and 3200ths. If I want to make this number match this -6, I'm going to have to subtract 1. So if I'm subtracting 1, then I must make the number larger by 1. So if I'm subtracting 1 from the base 10, I must add 1 by making the first number larger. So 1 and 3200ths, to make that larger, move it over to the right, and you have 13 and 2/10. Make the first number larger, make the exponent smaller. The second one, if I want to get the 10 to the -6 to equal -5, I will have to add 1, because -6 plus 1 equals -5. So if I'm adding 1 to the power of 10, I must make my first number smaller by 1. So I need to move it one place to the left. So that gives me 8/10 times 10 to the -6 plus 1. Remember, you make the first number smaller, you make the exponent larger by adding 1. So a -6 plus 1 is to the -5th power. So we're going to apply both of those rewriting of our expressions to have the same power 10 as the other by applying it to numbers 5 through 11. So number 5, it says find the sum or difference, write all answers in scientific notation. Well, first, I want to make my exponent a 5, which means I'm going to have to change 8 times 10 to the 4. If I make my exponent larger, I'm going to have to make the first digit smaller. So the decimal is behind the 8. To make it smaller, I need to move it one space to the left. Remember, if I make the number smaller, I make the exponent larger, so I must add 1 to that. So that gives me 8/10 times 10 to the 5th power. Now they both have the same power of 10. so I can now subtract them. So now I have 9 times 10 to the 5th minus 8/10 times 10 to the 5th. So now all I do is subtract my 9.0 minus 8/10. They both are multiplied by 10 to the 5th. I need to borrow. This becomes an 8. Carry a 1. 8 from 10 is 2. 0 from 8 is 8. So it's 8 and 2/10 times 10 to the 5th power is your answer. Number 6, we're going to make them both have an exponent of 7. Remember, if I make the first digit smaller by 1, I need to make the exponent larger by 1. So this gives me 4 and 7/10 times 10 to the 7th plus 34 hundredths times 10 to the 7th. So now I'm going to line up my decimals. 4 and 7/10 times 10 to the 7th plus 34 hundredths times 10 to the 7th. When I line those up, I'm going to go ahead and add a 0 in this place, and I'm going to add vertically. That gives me 4. 7 plus 3 is 10. Carry your 1. 4 plus 1 is 5. Bring down your decimal. Times 10 to the 7th power. Number 7. I'm going to make my exponents that have an exponent of -3, which means I have to add to the -4 only one digit. So if I make that number larger, I need to make the first digit smaller by moving the decimal over one place to the left and adding 1 to my exponent to make that a -3. So now this gives me 7 and 2/10 times 10 to the -3, subtracted from 68 hundredths times 10 to the -3. Okay? If I line up my decimals to subtract, I need to add a 0 in this place. So let me rewrite this. So this would be 7 and 2 20 hundredths times 10 to the -3. I'm going to borrow from my 2. This becomes a 1. And the 0 becomes a 10. So 8 from 10 is 2. Borrow from the 7, it becomes a 6. Carry your 1. 6 from 11 is 5. Bring down your decimal. Subtract 0 from 6 is 6. Times 10 to the -3 is your final answer. Number 8. Number 8, I have a problem written in scientific notation and one written in standard form. So I'm going to change them both to standard form and then change the final answer to scientific notation. If you look at 6 and 4/10 times 10 to the 5th, to put that in scientific notation, I need to move the decimal 5 times to the right. 1, 2, 3, 4, 5. In each of those places, I'm going to add a 0. So it gives me the new number, 640,000. And I'm adding that to 320,000. Okay, so when I add vertically, that gives me 960,000. And I want to make my final answer in scientific notation. So I need the decimal to end up between the 9 and the 6. So which means I move the decimal 1, 2, 3, 4, 5 times to the right. So my final answer is 9 6/10 times 10 to the 5th power. Number 9, we want to make this second number 3 and 2/10 times 10 to the -4 in standard form. So I need to move the decimal 4 places to the left. 1, 2, 3, 4. I need to add 3 zeros. All right, so now we're going to line up our decimals. I'm going to subtract. So that gives me in the place value 2. $2,2,0,0,0 in my decimal. So in order to make this into standard scientific notation, I need to move the decimal over 1, 2, 3, 4 times. So because my number was less than 1, it's going to be to the -4 power. And the last two problems, it says apply your knowledge of adding and subtracting with powers of 10 to answer 10 and 11. So Summersville has a population of 430,000 people, while Eagleton has a population of 5 7/10 times 10 to the 5th people. What's the difference in population of the two towns? The word difference means to subtract. So because it means to subtract, we're going to convert this number into from scientific notation to standard form, which will be 4 more zeros added behind. So 570,000. Difference means to subtract. So I'm going to subtract that from population of Summersville. So after I subtract, this gives me 140,000 in standard form. And in scientific notation, you move the decimal 1, 2, 3, 4, 5 times. Because my number is greater than 1, that's a positive 5th power. My last one says Kristen is using paper for an art project that's 25 thousandths millimeters thick. If she glues a layer of paper onto a construction board with a thickness of 7 times 10 to the -2 millimeters, what will the total thickness of the paper and the construction board be? If you want the total, that means you are to add in this problem. And also means to add. So I'm going to convert this number 7 times 10 to the -2 into standard form by moving the decimal 2 places to the left, which will give me 7/100. So now I'm going to add 7/100 plus 25 thousandths. So that's 590. So this is standard form. Scientific notation, I'm going to move the decimal 2 places to the right. Because it's less than 1, my exponent is going to be negative. Your homework tonight is to finish homework number 5, numbers 1 through 5. On the side of work, it says show your work. You're going to show your work. And then on the side that says solution, you're going to write your answer in scientific notation. They're all due.